Hi, my dear KPCL aspirants who are preparing for KPCL. Of course, you are preparing from last year, I think. 2017 notification, 2018 exam and 2024 exam. And again, now they are going to conduct a re-exam for AE and JE. Just within 30 or 35 days, we have an exam. 30 or 35 days, we have an exam on December 27th or 28th, whatever they given. So in this short time, we need to prepare. We need to do some hard work to get into the short list, yes or no? So for that purpose, we are going to start a live classes, live sessions, KPCL live sessions every day, daily around 5 to 6 hours of live, and if possible 1 hour exam and its explanation, etc. We are going to plan perfectly for your KPCL exam, sir. So for that, from today onwards, from 24th of November, we started live classes on this. For JE as well as AE or AEE, what it is called AE or AEE, for both the students, we started a live sessions, which is actually very important. This is not like a complete criteria. This is especially for examination point of view, because we have only around 30 to 35 days of time. In that 30 to 35 days of time, how we can cover all the syllabus, which is main important syllabus, like a power system, like a electrical machines, like a networks and measurements and control systems, power electronics, like that. Majority of the topics, UEE, utilization, like which are very important, and majority of the topics we are going to digital electronics and analog electronics. For AE, analog electronics important, networks important, and controls important. For JE, of course, power system and electrical machines and power electronics important for both AE and JE. So, like a maximum at least 70 to 80% of syllabus we need to cover in examination point of view. Most of the questions will appear in your exam. In that way, especially for a examination point of view, we are going to start. We started live classes. So who are interested, who are willing to prepare for our KPCL exam, so be ready, guys. This is a time to do somewhat hard work. In previous video also I told you that in these 30 to 35 days you should have any jobs. Your job is just preparation and practice. Surely you will get into the electricity board. So who are willing to join for this live, please call our mobile numbers. Please call our mobile numbers, SAIMEDHA mobile numbers 9494 891234 and 9494 861234 and 9494941234. Please call to these numbers. If you have any doubts, we will discuss with you, sir. Okay, guys. So, but just give me time of these 30 days. Then after you will be in the list. In that way, we will practice, we will prepare, no doubt at all. Okay, guys. So let's see here. I am going to discuss few questions previously asked in our KPCL exam, recently conducted exam. These are the previous questions in our KPCL exam on electrical machines. So what they are asked, a wave-wound DC machine has an armature resistance. They given armature resistance of 0.2 ohms. The resistance of each path is, they are asking. Sir, how many poles are there? No need of number of poles for wave winding. Because you know, in our DC machine we have a lap winding and wave winding. In lap winding, number of parallel paths equals to number of brushes. In wave winding also, number of parallel paths equal to number of brushes. But in lap winding, number of parallel paths equals to number of poles. In wave winding, whatever the number of poles, the number of parallel paths or number of brushes are 2 only. So in wave winding, we have only 2 parallel paths. We have only 2 parallel paths. These two parallel paths equivalent resistance they given as 0.2 ohms. Now they are asking what is the resistance of each path. Then immediately people will go for 0.1, sir, because two paths, right? 0.1 plus 0.1, which is equal to 0.2, which is wrong answer. Because they are connected in parallel, they are called parallel paths. This is 0.4 and this is 0.4. Then what is the equivalent? 0.4 by 2, which is equals to 0.2. Like that way you need to answer yes or no, guys. So the answer is C. Completely mind game. This is not a DC machine game. This is a mind game. They given here 0.1. They given somewhere 0.4. And what about lap winding? Lap winding used for low voltage and high current applications. Wave winding used for high voltage and low current applications. And what about lap winding? In lap winding, no need of dummy coils. No need of dummy coils. But here we need dummy coils. We need dummy coils. In lap winding, we need equalizer rings. We need equalizer rings. Here, no need of equalizer rings. No need of equalizer rings. What is the formula to possibility of equalizer rings? Is it possible or not? They will ask you. The equalizer rings, the number of equalizer rings is equals to number of coils by pair of poles. If the number of coils by pair of poles is a integer, then ultimately we can use equalizer rings. If this is not a integer, that is not possible to use equalizer rings. We'll discuss all those important things. So what is a condition to use dummy coils? Can you comment, please? Can you anyone comment? What is a condition to use dummy coils? Okay. What is the condition to use equalizer rings? Coils by number of pair of poles, or simply 2C by P. 2C by P is a integer, then we can use equalizer rings. Otherwise not possible. Like that. This is our easy question. And next question, let's go for next question. A DC to DC converter is used in regenerative braking, sir. They given regenerative braking of DC motor. The supply voltage is given as, for motor supply voltage is given as 600 volts and duty cycle is, they given duty cycle alpha or D is 0.6. If the armature current is maintaining at 250 amperes, armature current 250 amperes, then what is the generated power? What is the generated power here? See, simply the power is equals to EMF into current simply in our DC motor, of course regenerated power, of course. But what about this EMF are simply called the voltage output. The output voltage is equals to voltage input into 1 minus alpha, because here we need to consider it as a booster. DC to DC boosting mode of operation. Nothing but step-up operation. In that step-up operation, the input is 600 volts and 1 minus 0.6. 1 minus 0.6 is nothing but 0.4. So 0.4 nothing but, if you given 1 0 to them, 64 are 240 volts is a output, which is we considered as our EMF here. So tell me, what is here output? 240 volts. And what is the current? Current 250. 240 into 250, 0, 0, 2 zeros. 25 fours are 100, 0, 10. 25 twos are 50, 50 plus 10. 50 plus 10, 60. Have you understood? 25 table. Do you know or not? Malum hai? Nahi malum. 0, 0, I given here 0, 0. 25 table. 25 fours are 100. Out of 100, I placed here 0 and 10. 25 twos are 50. 50 plus 10, 60. Totally 60,000 is the power output. Not 6,000. Again, mind game. Not 6,000. 60,000 is the answer. See, many people will committed for mistakes here. Actually, this is a question from power electronic drives also actually. Of course, I am a DC machine faculty. That's why I grabbed here. Next. See, the transformer on no load. On no load, drawing a current of, the no load current of 5 amperes. and power they given 300 watts. Power they given 300 watts. When applied voltage they given 280 volts. Voltage they given 280 volts. Then they are asking its magnetizing reactance they are asking. Actually, this is very calculative question, sir. Not that much of easy. Mostly we need calculator actually. Otherwise we can't say actually. Let's see what we know under no load condition. Under no load condition, the power is equals to VI cos pi. VI cos pi naught. They given power 300, voltage 280 and the current 5. Now we need to calculate the cos pi naught. What is cos pi naught? If you calculate cos pi naught, you will get something. Cos pi naught is equals to 6 by 28. Whatever the value. Then after you need to calculate phi naught. Phi naught is equals to cos inverse of 6 by 28. You will get some value. How much, sir? For example, 0 point nothing but 60, 2s are 60, 28 to 2s are 56, again 4 is there. So 40, 1s are something 0.2 something. Approximation I am doing here. Exact answer we must need a calculator. 0.2 nothing but its value around 75 to 80 degrees in between. Around 75 to 80 degrees in between. Now they are asking magnetizing reactance. Magnetizing reactance can be written as X naught, right? What is X naught value? V by I mu. What is V? V given as 280. What is I mu? I mu is nothing but I naught sin phi naught, sir. I naught sin phi naught. I mu is equals to I naught sin phi naught. So what is the value? I naught is a 5, right? I naught is a 5 into sin 70 to 80 degrees. Its value sin theta, whatever, sin 75 to 80 degrees in between. 5 1s are, 5 5s are, 5 5s are 25 and 5 6s are 56 by something. If you calculate this, around sin 80 value, how much, sir? Around sin 80 value, sin 90 value, sin 90 is a 1. Mostly this value nearly 1, but not equal to 1. Its value nearly 1. Sin 91. For example, sin 80 nearer by 1, 0.9, etc. So the value nearer to 56. Nearer to 56. Only one option is there. See, actually, this is what we need in the competitive examination. Of course, they may allow a calculator or no, I don't know exactly. What you written already previously, you know that. If they not allowed calculator, I can give the answer. Even I can calculate cos inverse, I can calculate sin theta, very hard calculations, I can get the answer. That is what we need in competitive exams actually. Got my intention? Every one of you. So here X naught they are asked, X naught is equals to V by I mu. This is KPCL AE question. Somewhat tough question of course, but if you have a small grip on that, if you have a continuity of numerical practice, actually very easy. Let's go for next question. This is what I have to learn you. Here, what the knowledge I have to give you, that the way of solution, how we can approach the solution easily, that is what we need here. Next. The rotor input of an induction motor, rotor input, they are given rotor input of an induction motor at a slip of 2%. At a slip of 2% is 80 kilowatts. The gross power output of rotor. See here, what is gross power? What is air gap power? Here is called stator input. Here is called stator losses. Stator losses. Here is called stator output or air gap power or rotor input. Air gap power. Here some losses will be there, rotor copper losses. This is called rotor output. The rotor output is also called gross power output. From this gross power, again some mechanical losses will be there. Then after we can get the net power. We'll discuss. So what is gross power? Gross power formula, which is nothing but rotor output. Rotor output is equals to 1 minus S into rotor input simply. 1 minus S into rotor input simply. So how much? 1 minus 2%. 1 minus 2% is a 98%, sir. 98% of 80,000. 98% of 80,000. So 98% of 80,000. How much, sir? Two zeros cancel. So 98 into 8. 4 6 72 78. 72 78. What is the answer? What is the answer? 2% 80 kilowatts. So they are asking gross power output. So what is the answer? They are not given 78.4 kilowatts because the rotor input they given and 2% of losses is given. So here there is no exact answer. We can go for 80 kilowatts in this, no doubt. But actually he has to give the correct answer. Here 1 minus 2% of rotor input, 98% of rotor input, 9 8s and 8 8s are 64, 4 6 and 72 plus 6 78. So 78400. So approximately we can go for 80k again, which is a wrong estimation. Actually they given wrong. Yes or no, sir? We can calculate like this also. For example, they given input. Input is 80 kilowatts. What is the output? What is the output? Input is 100%. In that 2% of losses, 2% of losses, in this 2% of losses, so the output is 98% actually. We can calculate like this also. They may give you options wrong actually. They given a wrong options actually. Where is the question? Yes, they given same 10 kilowatts, 16 kilowatts, 64 kilowatts and 80 kilowatts. The output of the rotor gross power is they not given. So actually this is a procedure. 78,400 is the answer actually. We can expect question again in your next exam also. Very important like a model. Next. The net iron area of 3-stepped core. Here small conclusion, sir. Generally the transformers are preferred to use like a circular, but which is not possible. Of course in circular we can utilize 100% of core, but if you used 2-stepped core, this is called 2-stepped core, sir. This is called 2-stepped core. But here we can utilize only 85% of core. If you used a 3-stepped core, nothing but like this. 3 steps will be there. Like this. 1 step, 2 step, 3 step. 1 step, 2 step, 3 step. Like this. 3-stepped core. And even 1-stepped core also will be there, sir. 1-stepped core. Like this. 1-stepped core. Here we have some empirical formulas. Here the area of core is equals to 0.45 times of d square. It's a diameter square. The area of core is. Its area of core is for 2-stepped core. Its area of core is 0.57 times of d square. 0.57 times of d square. Here area of core is 0.6 times of d square. 0.6 times of d square. These are the empirical formulas from the geometry we can calculate actually. Just try to remember these empirical formulas. For 1-stepped core 0.45 of d square. For 2-stepped core 0.57 times. And for 3-stepped core 0.6 times of d square. Its diameter square. But here what they are asking, the iron area. This is total area and they given stacking factor. What is stacking factor? Stacking factor is equals to iron area by gross area. Iron area by gross area. What is gross area? Insulation area plus iron area combinedly called gross area. Simply we can call the stacking factor is equals to net area by gross area. Net area by gross area. Net area nothing but iron area. Gross area nothing but iron plus insulation area. So now the stacking factor is 0.92 is equals to net area. We need to calculate net area or iron area by gross area. What is gross area for 3-stepped core? For 3-stepped core, what is gross area for 3-stepped core? 0.6 times of d square. So what is iron area? Can you tell me? Iron area is equals to 0.92 into 0.6 into d square. 0.92 into 0.6 into d square. How much? The 0.6 multiplying with 0.92, nothing but less than 1. So the answer will be less than 0.6, slightly less than 0.6. Slightly less than 0.6, we have only one option. If it is multiplied with 1, answer is 0.6. If it is multiplied with greater than 1, answer will be greater than 0.6. If it is multiplied with less than 1, the answer will be less than 0.6. We have only one option here. Like that we can conclude. So these are previously asked in KPCL, which are very easy actually, of course very calculative, but if you have a clear idea, you can give the answer within seconds without any calculations, just by approximation. That is what we have to learn from the classes. Okay guys, are you ready? So on tomorrow 10 a.m. Tomorrow 10 a.m. we have a live demo in our YouTube channel. Live demo in our YouTube channel. Actually, how the class is going on. Actually, that is a regular class who already joined. That is a regular class for who already joined. Who still not joined. For example, if they want to check how the classes will be going on, for them, we are giving you an opportunity to attend a demo, live demo in our channel itself, here itself, in our YouTube channel itself, tomorrow at 10 a.m. Morning 10 a.m. to 1 p.m. Then after break and from 2 p.m. to 5 p.m. continuously class will be there. Who already joined, a few members, they are also attend the same class. Okay guys, so this demo on KPTCL, AE or AEE, whatever it may be, AE or AEE and JE, KPCL, not KPTCL, sorry, KPCL, AEE and JE aspirants, for them tomorrow at 10 a.m. in this YouTube channel, we are conducting a live demo. So this is only for limited students, not for everyone actually, who are interested actually. So who are interested, first of all, you need to register your name by calling to this number. Which number? 9494941234 or 9069881234. Call to these numbers and register your name first of all. So if you registered your name, then we will send you the YouTube link for you only. So that is comes to you, not for open. Who are interested, for them only we are providing this live classes. For registration, no fee. This is free demo simply. But you need to first register your name. You register your number, then only we will send you the link. So this demo by who, sir? This demo by the founder of SAIMEDHA, Dr.G.Ramana sir. Dr.G.Ramana sir, ex-Transco ADE, who has around 30 plus years of teaching experience and electricity board experience both, and sir plus in addition to any one of our team faculty based on the situation. So maximum sir will take you the demo first of all. So who are interested, please join in our live tomorrow 10 a.m. So who are interested to prepare your KPCL exam? So we started a live classes for KPCL especially, and you know already what is SAIMEDHA. Previously in KPTCL also many students are selected. Actually many of them you know already. They will encourage you, they will give you like a reference, join in SAIMEDHA, because they know what is SAIMEDHA, how we will give you the input, how we will give you the shortcuts, how you can experience. Okay guys, so who are interested, please feel free to contact for any details. Right sir?